Hey students, I just wanted to make this video for you so that it's kind of like a mock quiz or quiz practice for graphing quadratics. I've already added a video to the playlist. Let me show you. So you just go to mid, then portal, and then this video you would have had to do all of this anyway to get to this video, but I don't know if it does that for you, but so if you go to Moodle, then you'll see the YouTube playlist. Just choose the class you're in and then go to Math 105 YouTube playlist and it'll go to here. So I've added this thing. It says Math 107 and that's a different class that I teach at a different place. But if you go into it, it is this same kind of practice. So if you just want more video besides the one I'm currently making right now, then you can watch that. So we can turn it up so you can hear it. Okay. So it's just the same similar kind of problem, but what I'm going to do now is just kind of show you how to generate these things. The way I do them is I start with the quadratic in standard form. Well, I actually start with one in vertex form and then turn it into standard form by just expanding it. So like let's just say we're going to start with, I want my let's say I want it to open up. So in order to get it to open up like this, a has to be positive. So opening up means a is positive, so a is 1 in this case. Remember that standard form is a times this squared, like that. So I'm just choosing an a, h, and k. So like if I want a positive h and a negative k, like let's say I want my vertex over here, well, let's say I chose a to be 1 because that's the easiest thing to do. Let's say I want my vertex to be at 3, so I would do minus 3 squared, and then let's say I want it down 10. Okay, so that's, sorry about the focus there. Let me try to change that focus. There we go. So I would just do this, and now I just expand that, and then this gets you in standard form. So start the problem here. So let's say the problem was graph f of x equals x squared minus 6x minus 1, right? That would be like the problem I would give you. Okay. So then you would proceed. So you would find the vertex. Let's assume you didn't know what it was. You would just go h is negative b over 2a, which is 3. Then k is f of h. So that's 9 minus 18 minus 1. It's negative 9 minus 1 is negative 10. Okay, so you can get these two numbers from the standard form. And then now you can say, well, it's in, so a is 1, so there's no number in front. X minus 3 squared plus negative 10. Alright, so obviously you're going to get back to where you started, but this is how I'm going to create the problem, but that's not the problem I'm going to give you. I'm going to give you this problem, so just pretend that this never happened. Alright, start here, and work it through. Once you have it in standard form, you can get the zeros by just setting it to 0. Okay. That's square free, so we don't have to do anything to it. Alright, now we need to get some decimal approximations for those, because for putting them in a table we need decimal approximations. So x, let's get a calculator. Okay, oh, that was messed up. So let's get these numbers. So 3 plus or minus square root of 10. So 3 plus square root of 10. Alright, so 6.16. So I know that the next one will be, 3 to the other side. So I'm guessing it'll be 0.16. Just check it just in case. Oh, see, I was wrong. Yeah, you have to subtract 3.16 from 3. So it'll be negative 0.16. It's always a good idea just to do it on the calculator. Okay, now those are symmetrically on either side, right? I went from 3 forward 3.16 and from 3 backward 3.16. Alright, so with this we can set our table up. Now 0 falls barely within that range, which means that we need to have the y-intercept first. So that's what I'm going to do. I'm going to set this up. So I'm going to put my vertex in the middle. 3, negative 10. And now I know I want my y-intercept. So if I'm putting it in descending order, this number's bigger, so I'll put the y-intercept here. So its friend has to be here. And the y-intercept is c. C when you're in standard form. Okay, and then you get the 0 that's slightly less than that. So those are almost going to be right next to each other. We know that's 0. And this one will be barely off of that one. Then we just choose another point. So if you put 7 in the formula, you get 4 squared is 16 minus 10 is 6. So then negative 1. So that table of values ought to get the job done. Now we'll set our axis up, mostly looking at positive x's. So I'll go like negative 2 to 8. Next, there's a y-axis. So we'll see every number in this list from that range that fits in there. Now I need to see negative 10 all the way up to 6. So let's go negative 12 to 12. That's simple enough because that's easy to split in half a bunch of times. Negative 12, negative 6, negative 3, negative 9. So it looks like I'm going by 3's here. So that is a good way to scale the y-axis. So now we just plot these. So I go forward 3, down 10. Forward 3, here's down 9, so down 10 would be about right there. Here's our vertex. Now it's easy to plot the y-intercept. And then its friend would be 6, negative 1. And then this number here, negative 0.16. 0.16 is, I think, about 1/6. Yeah, so if that's negative 1, it's like half of a third. So, I mean, you're barely off of there. No, it's kind of unfortunate, but that's what happened there. And then 6, 7, 6. So here's 7, we go up 6. And then negative 1, 6. Alright, so I'm going to try to choose it so that this doesn't happen, but it did in this case. If I had made my vertex closer to the y-axis, it makes it less likely that this is going to happen. Okay, so you can check it if you have a graphing calculator. You can just set the window up exactly the same way. So I'm going from -2 to 8 on my x's, and skipping every 2. So my x min is -2, my x max is 10, and I'm going by 2's. And then I went -12 to 12 on these, and I went by 3's. So now if I just put, it doesn't matter which form I put in there, it probably is better just to put the standard form version of it in, the one that you started with. So x squared minus 6x minus 1. You just graph that now, you should see pretty much what you drew. Yeah, see that? See how it barely misses the origin there? We expected that to happen. So that's the idea. Let's try another one. Another interesting program to check out if you're interested, something called GeoGebra. You can download it for free. It'll run on any system, and this is a fun one to play around with because you can like make sliders if you want, or you can define a point. Just make it any old point. Like let's say you wanted, let's do 3, -10. Right, I've got this point, but I can grab it and move it around. Okay, so let's say we just want to, if you look over at our information here, what's relevant here? A, H, and K. So let's play around with this. What A does is it tells you how much it widens or scrunches, right? So let's determine an A. Let's just say A equals 1 for now, because that's what we just did. But we can make it a slider. See, it created this number up here, but then you can highlight it and it makes it into a slider. We can force it to be an integer if we go to Object Properties and make it just go increments of 1. Okay. So now what we can do is we can just we can define H to be, so H equals, see I'm down there in the input box. I'm going to say H is the x coordinate of A, the point A. Right, so it just created a number H equals 3, and K is the y coordinate of the point A. Okay, so now you see as you move it around it does that. So let's define a function to be f of x is a times x minus h squared plus k. Not sure what, oh, a is 0. That was confusing. Okay. So if we make h to be 3 and we just move this to -3, you can actually make it show a grid. Oops, I gotta get off that point. But you can have it show a grid, which is kind of nice, and then it might snap to the grid. So we were at -310, so we're down here. Or I'm sorry, 310, 3 -10. Right? You see what it does? It looks like what we expected it to look like. So this thing is really nice because you make A whatever you want. You want to practice one where A is 2. Okay, and then just move this thing so that you're not having like these two things really close to each other. Let's put it over here for now. Let's go right there. That's a good one to practice. See that? Now it gives you the formula. And you can even, now there's an option in this thing, it's called a CAS, which is really cool. View CAS. And then you can tell it to expand. And then you just hit enter for, and then you enter expression. Well, I just wanted to expand f of x. And it does it for you. It puts it in standard form. And I think this thing is going to react to my changes. See this? That is amazing. It just expands this thing for you. So what do we have right there? So this would be where the problem starts. And you can change your a. You see what I mean? It's like, it's pretty sweet. So this will be the problem I start with. So let's just bring this up here. Let's set a new problem. So let's make A2. That's what we started with before. Yeah, that'll be a nice one to do. So we're going to start by trying to graph f of x is 2x squared plus 4x minus 3. Okay? So what do? We begin, so a is 2, b is 4, c is negative 3. Calculate h, negative b over 2a. That's negative 4 over 4, which is negative 1. Right? That corresponds to the axis of symmetry. K is f of h, so 2 times negative 1 squared plus 4 times negative 1 minus 3. So we get, this is 2 minus 4 minus 3, so that's 2 minus 4 is negative 2 minus 3 is negative 5. That's right where we expected it to be. So now we can put this in standard form. We get f of x can be rewritten as a x minus h, so plus 1 squared plus k. And that's of course what we started with over here, but that's neither here nor there. We know it's right. Okay, so now we can just set it to 0 to get our zeros. So we get this. So 5 halves. Now I'm going to square root. And this is where we're getting that weird, so plus or minus, it turns into that with an irrational number in the denominator, so you have to rationalize that. So we're getting plus or minus root 10 over 2. Okay. So then we subtract 1. X is negative 1 plus or minus root 10 over 2. So let's get these two approximations. We just use the calculator to do that. Okay, so quit this whole thing. So negative 1 plus root 10 over 2. I'm getting 0.58. So that's, I'm not even going to try to do the symmetry. I'm just going to do negative 1 minus root 10 over 2. Negative 2.58. Okay. So the 0 falls in that range, so we're going to want the x-intercept first. So when we make our table, I mean, you can look at your graph here and see if those numbers make sense. It's a little bit more than half and a little bit less than 2.5. Those look right to me. Okay. So we know we want to put our center thing to be HK. And then the y-intercept is in between these two zeros, right? Like there, you know, there 0 is in between these two numbers, so we put 0. It goes above it because we want this in descending order, just to be clear of what's happening. We know that that's -3 from standard form. So going, its friend is going to be on the other side, has the same y-coordinate. Now we go to the zeros. So this one is above. So 0.58 gives us 0, and -2.58 also gives us 0. Then 1, putting 1 in this vertex form up here, it would be 2 in here, squared is 4, doubled is 8, minus 5 is 3. So then this would be -3, 3. Okay, so that's a simple way to generate that table. And we look at this range of data, -3 to 1, so I'll go -4 to 2 on the x-axis. Y-axis 2, whatever, that's fine. And then these numbers are ranging from -5 to 3, so I'll go -8 to 8. That'll be, or -8 to 4. That'll be fine on the y-axis. 4, -4, -8. It's really nice because it's super easy to break those in half, or even into integers if you need. Okay, so now we just plot these. So -1, -5. So this is -6. There's -5 right there. Let me just get our integers in there, just so we don't screw this up. -1, -5. Then 0, -3. And then -2, -3. Then a little more than a half. So that's 1. So that's a half. So a little more than that. And then a little more than 2.5 this way. And then 1, 3 would be here. -3, 3 would be here. So yeah, we get it. And that more or less corresponds to what we have here. And then of course, if you don't have that handy, you just put your standard form thing in here. 2x squared plus 4x minus 3 is what we had. Yeah, it's right there. And then we set our window up. We went -4 to 4 and -8 to 4. So -4 to 4 is what I did here, and I went by ones. I went -8 to 4 to 4 and went by ones there. So now this will graph exactly what we just did. So yeah, that's corresponding pretty darn well to this thing. This will always be prettier than your drawing. It's not coming to a sharp point like that. It should come almost circular at the bottom, but whatever, doesn't matter. I mean, it's not a beauty contest. So hopefully that gives you an idea. Watch that other video for more practice if you want, but thanks for watching.